So this table is on page 219. I don't know whether we may get to the bottom line of it today, but we won't get to the top 4 lines. And that kind of has pretty much everything you need to be able to explain or describe for these 4 electrochemical reactions. Before we get into that, we just have to understand what electrolysis is. So when we do ionic bonding, we are adding negatively and positively charged ions together. It's the force of attraction between them. When we do electrolysis, we're actually going the other way. We're breaking down ionic compounds into their ions. And yeah, we'll get into the half equation thing. So I need to change my share.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting 2 electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the 2 bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge. In this case, electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this process in our lesson Interpreting Electrode Equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cathode, it attracts cations. The liquid is effectively conducting electrical current. The only difference is that the charge carriers in the liquid, in other words the charged particles that are moving, are ions. If a liquid has free-moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We'll be studying several examples of electrolysis in more detail in other lessons. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.
Okay, so that is, I don't know whether it made a lot of sense, but it is a really good video in terms of explaining what's going on. So we're using electricity to actually bring about chemical reactions. So on page 204, we have some words that we've got to figure out today. I think that's all we'll get done today. So I use this thing panic to help me out. So electrolysis, the gentlemen in the room may not be aware of it, but ladies get little metal wires stuck into hair follicles and electrocuted to remove hair, but this is a different version of it. So we're using electricity, we're passing it through an electrolyte, and the whole point is to have a chemical reaction. So then we have some words. Okay, and just the part of this that you want is that it's either molten or aqueous substances. So electrolysis is using electricity to bring about a chemical reaction, and your electrolyte has to be molten or it has to be dissolved in water, aqueous solution. So this is characteristics of your electrolyte. So if under electrolyte you just want to put these in, it has to be molten or aqueous. Everything else is more an FYI. We will talk about everything else as we go through. Okay, so trying to judge from you, I'm going to say it's yes. So we've just done that. So then in terms of our electrolyte, as well as being molten or dissolved, it is the substance through which our electrical current is going to pass. The electrodes are the rods that make contact with your electrolyte, and you have two types of rods. They can be what are called inert. So inert are unreactive, they're like the noble gases, but what they will do is they will carry current, and they're either platinum or carbon usually. So when we have these rods inert, they don't take part in the reaction, but if we have active electrodes, they will take part. So I'll just put this in brackets for you. So this is the copper in copper sulfate. They are active electrodes. And we've seen spectator ions before, so these would be in an equation, or sometimes when we get redox and we just get the ions in the equation, the spectator ions are taken out because they don't take part. Their oxidation state doesn't change. So similarly for electrolysis reactions, we will have ions in solution that will be spectator ions. They don't take part. And usually the reason for that is there's not enough energy in your system to make them get involved. So they'll just sit there. Okay. Alrighty, so here's now panic. So panic in my head stands for positive anode and negative cathode. And way back when we did Form 4, when we were doing cations and anions, we had posi-cats. So it was that lovely quality diagram, I'm sure you all remember it, of the little cat with the little positive smile, and then there was a very quality diagram of a little ant, and he has little negative eyes, and he's got his little ant bodies, but he's got little negative feet as well. So cations are positive, but now in terms of our anode and cathode, we have a positive anode and a negative cathode. I'm also going to introduce you to anox and a red cat. So oxidation is going to happen at the anode, so you already know oxidation is loss, and reduction is going to happen at your cathode, and reduction will be gain of electrons. So that's going to help you to write your half equations. So I think the anox and the red cat, they're at the bottom of the page 204. You also have this little diagram down here. So what this is showing you is that it's a picture of a cell, a battery, power pack, whatever it is, but it's always going to be drawn whereby this line is much bigger than the other line, and the very, very big line is your anode. So if they're not, the SEC won't always put signs in, but you have to recognize that this is your anode, because it's the positive terminal, and this is your cathode, which is your negative terminal. So the SEC won't always have the signs in. You will have to be able to recognize them yourself. So the bigger line is the anode, oxidation, positive. Small line is the cathode, reduction, negatively charged terminal. Okay, yeah, big line is the positive. And just that, in terms of your anode is going to attract your anions, which are negative, and your cathode is going to attract your, I think this will let me erase now, will attract your cations. So we're building now on what we did in Form 4. Okay, I'm assuming everyone is happy. So you have this version of your picture here. So this is obviously our anode side. So this line here all the way, that is your anode. This electrode will be positively charged, versus over here on this side, this is your cathode side. So that terminal will be negatively charged. So if anode is where oxidation happens, oxidation is loss of electrons. So I'm just going to change the picture slightly. You don't have to draw in the extra bits, but this is where oxidation is happening. So you are going to have electron loss here. So what's actually happening is the electrons that are there are actually traveling up your electrode, and they're maintaining the circuit. Whereas over here on this side, you're going to have reduction, because it's red cat, and reduction here, you're going to have a gain of electrons at this terminal. Now, if you have a bulb in your circuit, it'll light up because your circuit will be complete. And your electrolyte here is maintaining the circuit, so it's like an invisible link between both electrodes. So your electrolyte will conduct the electricity. Electrolyte conducts electricity. Okay, so Izzy, you're the only one I can't see. I can see you now. Yep. Okay, so you have, there's 5 little experiments that you have to know. The 2 that are underlined are higher level. You need to know at higher level the half equations for all these 4. We're only going to have a look at this first little one today just to show the movement of ions under their electric field. It's just kind of to give you an idea what's happening in terms of your cathode and your anode. So if you want to look at page 219 and maybe put this in at the bottom for yourself, you can. But in terms of every experiment, you need to consider what are the electrodes, what's the electrolyte, what's happening at your anode, what's happening at your cathode, and are there spectators present. So I am going to...
I think it might be 206. Is it the big table?
Yeah, is it the big... What type? It's page 219, I think, on mine. Or 207, sorry. Apologies. Find this one. So we can't even do this particular experiment in school anymore because it has chromium in there. So we are using copper chromate in this, and copper chromate is green. And what we do is we essentially put the copper chromate in the middle of a piece of filter paper. We stick it on a piece of glass. The filter paper has dilute hydrochloric acid in it, so that's going to help carry the current. So in that black line in the middle, that's actually our copper chromate. And once you apply the electric field, you will separate the copper, because it's positively charged, will go toward the positive anode, negative cathode. Oh god, that's what I do. So our anions will go towards our anode, and our cathode will go towards our cations go toward our cathode. But what it happens is because the ions are attracted, they will move, it'll literally separate out into its components. And this just proves that ions will move in an electric field. Does that make sense? So we have dilute HCl to carry our current. Okay, so in terms of your little table, let's see what you see. So in terms of our little table, our electrodes in this one, the electrodes are inert. They are just there to carry our current. So we have, so the copper chromate is what we had. See you. That is right. Yep. No, it's not. Apologies, I've done that wrong. Okay, so the copper chromate is green in color. So if you want to just stick green above the word. Our electrolyte is just dilute HCl. So that's going to carry our current. We then look at what happens at the anode. So at the anode, it goes yellow. And the reaction...
Chemist.
Yeah.
Where are we putting this in?
This is going into the bottom row of that big table.
Okay.
So the anode is yellow, and in terms of our reaction, it is the CrO4 minus goes to anode. In terms of our cathode, the cathode goes blue, and in terms of our reaction, it is Cu2 plus is going to the negative cathode. And in terms of our spectator ions that are in there, it is just the H plus in the HCl and the Cl minus. So they're present, but they're not involved. So this is just proving that ions will move in an electric field. Now they've never, ever asked this experiment, but it's there just to give you an understanding that if you have ions and they are in an electric field, cations will go toward cathodes and anions will go toward anodes.